Hey everyone, my name's Winston, and welcome to Intro to Docker for Data Science. So this workshop is sort of meant to introduce you to Docker if you haven't heard of it before, haven't used it before, and we're specifically learning about it in the context of data science. So just a little bit overview of the workshop. This is sort of intended to be for beginner to intermediate data scientists. So if you've never really heard of Docker before, this is great. And I'll be going over everything about Docker. And just some helpful prerequisites to have for this workshop. Uh, Being familiar with the Unix shell, being familiar with Python package managers such as pip, conda, and the Python language itself would be really helpful. And if you want to follow along with the hands-on examples, if you have Docker installed on your computer, then you'll be able to do that. So in this workshop, my goal is that you'll be able to understand the importance of Docker and how it's used. And we'll go over some examples such as creating and running custom images with Docker files, setting up a Jupyter Notebook instance using Docker, and launching a basic predictor service using Docker. So the overall outline of this is we're going to first look at what Docker is and why it's useful, differences between Docker and virtual machines, and then we'll just move on to the more practical hands-on examples of using Docker. So let's first start off with the problems with sharing your project. If you guys have ever been in like co-ops or whatever, or if you ever wanted to share your project with someone, and you know how you have a bunch of dependencies like installed per project, you tell them to install all of this stuff in order to run your code, and it just breaks. And then you're like, but it works on my machine, right? So that's a really common problem. And to ensure that we have our projects run consistently across different machines, we have to account for the following variables. So things like the version of Python that you're running, what kind of libraries you have installed on your Python, and like library versions, as well as the OS and OS version. A lot of people don't really think about the last two things, but having differences in the OS can actually sometimes make or break the way that your code runs on different computers. So when you don't have these like things consistent across these sort of factors consistent across all the computers, you might run into issues where your code is breaking in production, essentially. So what are some potential solutions to this? Well, first of all, we could use virtual environments, and some of you may have experienced using this before. Things such as like VN in Python, Conda, etc. And we just install all of the libraries that we need for a specific project. We install it into a virtual environment and then set up a requirements.txt file and send it to somebody. So this is really easy to learn and also to implement, but the con to this is that it does not account for discrepancies in the OS. So things like if you're using a Windows computer compared to a, you know, to a Linux computer, you might run into issues with the code or if something breaks. The second solution that you can use is using a virtual machine. So this allows you to account for the OS in the image, and basically the image is like the snapshot of like your computer if you want to keep things consistent. So we package up, and on top of all of the code that we're packaging and all of the libraries, we also like take a snapshot of the OS. But this often means that VM images become very large. They become like over 10 gigs, right? Because it contains an entire OS in it. And then when we're actually launching it, it takes even longer to spin up. And then the third solution, which is what we're going to be looking at today, is using Docker. So the pro with this compared to virtual machines is that images are typically very small. They're normally less than 1 gigabyte, and they're because of this, they're very, very quick to launch and tear down. But the only con is that you don't really see too much of a benefit when you're using Docker on a small project. So let's just go over, like, I've been talking about Docker this whole time, but like, what exactly is Docker? In layman's term, it's a tool similar to virtual machines, which basically allow you to run projects consistently across different machines. But unlike VMs, Docker images are very lightweight and they can be quickly launched and torn down. And finally, they allow us to run multiple applications in completely isolated environments. So at this point, does anyone have any questions about the stuff that I'm talking about? I know that I mentioned like VMs and virtual machines a lot, and some of you might not even know what that is. So let me know if anyone wants me to explain what a virtual machine is. Yep, Kevin has raised his hand. Go ahead, Kevin. You can type it in the chat. I'm not sure if you're allowed to speak here. Okay. Well, if there isn't a question, I don't think I heard what you said, Kevin, by the way. Okay. You'd like for VMs to be explained further? Um, okay. Actually, I was waiting for you to ask that to segue into this illustration here. Right? So basically, virtual machines, you can think of them as some as like a virtual computer that's running on your computer, right? Kind of mind blowing. But basically, virtual machines they tend to be like another running OS that's running on top of your computer. So, for example, if we look at here, this application A, perhaps your computer you have your computer here, and then the hypervisor which manages all these virtual machines. And then this one might be running Windows, and it's like running some sort of service or a server, I guess. And that's app A. And then there's like another virtual machine here, which is running perhaps Linux or something like that. But basically, all of the resources that this computer has, which I guess we can think of as the infrastructure, is split among all of this. But the biggest thing is um, because virtual machines, they have like uh, they require you to like run the entire operating system. Like let's say if this was Windows, right? You're gonna have to use up a lot of RAM for that as well, and just a lot of CPU usage. But if we look at Docker here, essentially we have the base computer, which is the infrastructure, the OS, and then Docker is on top of that. And Docker just manages the apps itself. It doesn't really care what kind of operating system is running because we just have our containers in that. And all of these are supposed to be like very separate. Anyways, are there any questions right now about what I explained? Okay, cool. I'm just gonna move on for now. Okay, so I talked a lot about Docker images and stuff like that, but let's actually get into the terminology of what all of this means. So a Docker image, it's a lightweight, it's basically a piece of software that includes instructions for how to run up uh, and how to run an application. So it contains all of the code, the runtime system tools, libraries, and settings. And basically, like with a image, you can you it just contains everything that's like required to run this machine basically. A container is a running instance of a Docker image. And this a container is completely isolated from other containers. They're isolated from the outside world if you don't put any settings on it that allows it to um, speak out, like contact the outside. And yeah, it's just completely isolated. A Docker file is a set of instructions written by the user to create the actual image. And a volume is a persistent data storage within a container or in a container. So volume, it basically links your local computer to or a storage, like basically a folder on your local computer to somewhere in the container, so that you can share the files. Because otherwise, as I said, a container is completely isolated. It can't even like have any access to your local computer. And a base image is basically what we build upon when we create Docker images. All images are created by are building upon other images. And the very, very OG base image is called the Scratch image. And I don't know exactly what it is, but um, like I can't explain it that well. But essentially, it's like a very, very bare bones computer. It doesn't even have like Linux on it. If you think about it, you'd have to upload some sort of like binary to it and like actually install shell and all of that stuff. But we usually do not work with base image or the Scratch image at all, especially in this introduction workshop. Okay, so let's go over a workflow of how we would set up like a single container in Docker. So as I mentioned before, the Docker file is something that you have to write. It's like a set of instructions on how to build a Docker image. You run Docker build on it, and that creates the image. And once you actually run the image, it becomes a Docker container that's constantly running until you shut it off. So yeah, let's dive into our very first exercise. Actually, before we do, does anyone have any questions about like the stuff that I talked about?
I have a little comment.
Yeah, for sure.
So I noticed they said that Docker containers are kind of isolated, but in reality,
Mhm.
they seem the same. They share the same kernel space with the host operating system, so they're kind of vulnerable to like side channel attacks as well as some privilege escalation vulnerabilities.
Oh, I see. I actually didn't know that.
Yeah,
Thanks
because
for pointing
Docker is
that out.
it's based on chroot.
Right, right. Okay, that's really interesting.
Yeah, so
So
they're not
yeah.
necessarily isolated, as in like
Mhm.
technically you could kind of escape them a little, I guess, easier than a VM, but like it's still pretty hard to do.
Right. Okay. Okay. That's really good to know, guys. Thanks again, Michael, for the comment there.
Yeah, no worries, but everything else is like dead on.
Right. Okay, cool. Okay, I'm going to stop sharing now to begin sharing my desktop. And I will also give you guys some files. Like, actually, does everyone here have Python installed on their computer? Just throw a yes in the chat if you do. All right, cool. I will proceed. Give me a second. I just got to pull everything up on my computer. Mhm. Okay. All right. Sharing my screen now. Okay, cool. Can everyone see my screen here? All right, cool. All right, so to begin, we're just going to start off with a very simple sort of like hello world example. We're going to be building or creating a very small like Python app and just running it with Docker. So first thing I'm going to do is just create a folder, call it hello world. And I need my terminal for this as well. You guys feel free to use command prompt or terminal, whatever you're more comfortable with. The computer I'm using right now is Windows, so I am kind of limited like to the type of commands I can run, but I think we can still work through this pretty easily. Okay, so let me go into my desktop first of all. Sorry, I keep forgetting I'm not in Linux. Okay. So if you have Python installed, what we can do is create a virtual environment in this hello world uh, app we're going to be building. And to do that, I'm just going to run vn and run it in here and name it hello world. And this should start building our environment. Okay, cool. And we're going to activate the environment. So we just go into the scripts and we're going to run activate.bat. So essentially now I'm inside of a virtual environment. If you guys are familiar with this, it basically means like I have a fresh install of Python. Nothing's installed on here. And for this project, we need to install Flask. So let me do that. Pip install Flask. All right, cool. And now I'm just going to pull up my editor and open that folder. So that would be in hello world. So a very easy sort of like web server, Flask server. So I'm just gonna import Flask right now, import Flask, and then set up this whole app. Oh, Hashim, you missed the commands after vn. Yeah, sorry, I was going a bit faster. But basically, we did python-m VM hello world n, and basically this just means create inside of this folder here, hello world, create a virtual environment called hello world n, and then I cd'd into the actual file. Let me try to find it if it's here. And when I run activate.bat, it basically activates the environment. So that's what I did. I cd'd here and I ran activate bat, and that put me into the actual environment. And then now I just did pip list to show like what kind of packages we have installed, and then pip install Flask to install the library. Okay, no worries. All right. So now at this point, I just made a new app.py file, and that's just to set up like the Python application. And it's a lot of boilerplate code. Like, not gonna concern you guys too much about what's happening here, but let me. After I write this, I will actually just paste it into the chat if you want to follow along with everything. But essentially, this just makes a very simple web page that says "Hello World," and I will put it into the chat. Okay, cool. All right, now we're actually going to get into the nitty gritty of this. We're going to create a Docker file, and as I said before, the Docker file is like the set of instructions that tell your Docker how to create the image, and yeah, we're gonna go from there. Sorry, let me just pull up something. Okay, so as I mentioned before, there's an instruction. It's called from, and this from basically tells like Docker which base image do we want to pull from, and the base image that we're working with today is going to be a Python image. So it's Python 3.8. Let me actually go to Docker Hub to kind of show you guys what's happening. So when I go to search up Python, so Python is basically the base name. If you think of sort of, actually, it's not similar to the GitHub, but basically we're just pulling this image right here. And the one exactly that we're pulling is the 3.8 one right here. And you can see this is actually another image. So as I said before, Docker images are built upon other images, and we're just adding to this now. Okay, anyways, so back to this. We're going to be pulling pretty much a copy, I believe, of, let me check. I'm not sure what kind of Linux it uses. 3.8. Okay, actually, there's a bunch of versions. This might be Debian, or it might be something else. Yeah, okay, but basically, we have a Linux. It's like pulling from a Linux computer and then installing Python on it. Now, the next thing we're going to do is set up a work directory and then call it app. So basically, what this does is that inside of our technically like the Linux computer that we're working with, it's going to create a new folder or a new directory called app, and then set the working directory to that. And then we're going to copy dot. And I think there's like some documentation within VS Code, but basically the first argument tells like the command, the source file that you're pulling from, and then the second argument is like where you want to put it into. So we're currently inside of this app directory. It's going to pull everything here. So excluding the Docker file, it's going to pull the app and hello world and into the folder. And then run basically executes a command, right? So we're just going to execute. Oh, wait, I forgot one step. Okay, back to here, back to our command line. I'm going to go back into the base folder. So we're still inside of our current, I guess, virtual environment. If I do pip list, you can see all of the packages I have installed here. I want my Docker image to install all of these packages. So I'm just going to freeze all of all of the package requirements into a text file. So the text. So that created one, and it's all here. So then now, once I copy everything over, it's going to include this requirements.txt as well. And inside of the, I guess, we're just going to call it the image, or like, yeah, within the image, we're going to ask it to run this command called pip. We're going to make it run pip install and install the requirements. .txt, because everything here is going to get copied into our image. And the very last thing that we want to do is just run Python and to run the app. So I'm going to do app.app. Wait, actually, just need to do app.py. I believe this shall work. Okay, let's actually start building the image. So I wrote the Docker file, and now I want to build it. One more thing that I forgot is that we want to create a Docker ignore file. So if you guys have worked with Git, this is very similar to like Git ignore, but we don't. This environment doesn't really concern like the Docker image, so we're just gonna exclude it from getting put into the Docker image at all. So we're gonna exclude that. Okay, cool. And then now we do Docker build and then dot. It should build an image for us based on the Docker file. And because all Docker files should have the name like Docker file, it just basically means we don't need to specify where the file is. Like within this folder here, hello world, it's going to look for a Docker file. Okay. So it's building. So as you can see that lots going on here, but basically what's happening is that it's downloading the base image, which is the Python image, and it's also doing all of the building everything that we specified inside of Docker file. Does anyone have questions at this time? While we wait for this to work. I got failed to create an LLB. I don't think I'm not sure how to fix that problem. Unfortunately, I'm sorry. Let me quickly search that up. Yeah, I'm not too sure. From requires 1 or 3 arguments, and you followed along exactly with this. I'm just going to paste all of the commands in here. Okay. I'm really sorry. I'm not sure how to fix it. I think at this time you can just follow along with I mean not follow along, but just like watch what's happening because we're almost there to the end. Yeah. Okay, cool. I think I forgot to put a tag on this. Let me just double check that. Okay. Yeah, so one thing I forgot was if when you build your Docker images, you have to give it a name. And the way that you do it is by giving it's what's called a tag argument, and you just give it some sort of name. Just call it hello. So you can see here, I have the Docker desktop pulled up, and then now we have this. From here, so like I have all of these images, and if you refer back to what I said previously, images are like instruction. It's like an executable, right? We need to run it still to turn it into a container. So we're gonna run it now. We can either do this through the interface here on the Docker desktop or just through the command line. I'll do it through the command line, but feel free if you want just to click on the run button here. So I'm gonna do Docker run and run hello world. If I typed it right. Interesting. So it's not persisting. And I think I know what the problem was. It's because I forgot to tell it to run it as a Flask application. So I believe this should run it as a Flask application. Just to double check here. So I edited this Docker file. I'm gonna have to rebuild it again. Just gonna rebuild it. And Docker run. Okay. I forgot what the commands were for running a Flask program. Okay, Flask run. Cool. Flask run. Okay, just gonna rebuild this. Switch this up. Sorry guys for taking so long to do this. Flask run. Okay. I think I know. Okay, it's going to rebuild it again. All right, finally. So we got this running. Let's see what happens when we actually try to visit the website. That's interesting. It says it's can't be reached. And the reason why this is because, as I said before, Flask containers are completely isolated. Currently, this container, it's not even reaching outside of, the little thing it's running in. So in order to get it to I guess connect the port of 5000, which is where our Flask server is running, to our 5000, we can give it a little argument when we do Flask run or Docker run. So when we do -p and then we write 5000 to 5000, that means map the port 5000 from within the container to port 5000 on our current computer to our local computer. So I'm just going to run hello world again with this additional command. Okay, it's still not working. All right, that's really interesting. Hey guys, I'm not going to try to take too much time because I've already spent a lot of time debugging the other thing. I'm just going to move on to step 2. But essentially, once we run this, it should show us our website on our local computer. But for some reason, it's not. I'm just going to double check though that it's not on localhost. Okay. Cool. I think it might have to do something with my firewall on the computer that I forgot to set something. Anyways, let's move on to the second exercise. Okay. Give me 1 second. So the second exercise that we're going to work with is just pulling a Jupyter notebook image from Docker Hub and running it. And this is something that's fairly common that you have to do. Or it would be really useful in data science because a lot of the times we have like environments that are set up, or it's hard to set up an environment for data science, especially with Jupyter notebooks. It's a very long and painful installation process. But here I can show you how like quick and easy it is using Docker. So I'm just going to send this link to you guys. But basically, Jupyter has already created a couple of images with the different notebooks, like different flavors of Jupyter. So for one, we have the base notebook image, which is only Jupyter with nothing installed on it. It's basically just Python 3 and Jupyter. We're gonna skip over minimal notebook. One really nice one I like is the Scipy notebook because it has everything that you need to basically do some data like machine learning stuff or data analysis. The more important ones being Dask for distributed like basically NumPy and pandas. There's Matplotlib. We have pandas in it and scikit-image, scikit-learn. And this is overall just everything you need to do like data science already. We also have like a TensorFlow notebook and a data science notebook. For today's example, I'm just going to install the base notebook and run it. So let's sort of go over how we would do this. Let me open up Terminal again. So it's as simple as just doing Docker pull and Jupyter / base notebook. And that I've already cached it. Let me do this again. Oops. Okay, but it's already installed on my computer, but when you guys run it, it should take some time to download the image. But if we take a look at this, you can see that this is also essentially just a Docker file that we're downloading. It's another image, basically, and it has a bunch of commands in it and everything. And then if we look at the Docker Hub, we can see that Jupyter is an account and they have different notebooks, basically repositories listed here. And then if I wanted to pull something, from them, let's say Scipy Notebook, I could take a look at their different like Scipy Notebook, and they also have tags. So like the latest version of the specific image, or like a specific version. So I just want the latest image, and by default, if you don't put any tags at the end, it just basically pulls the most recent image. So I'm gonna paste that in. And you can see how it's downloading. So with Docker, one thing I have not mentioned during our slides is that it caches some of the commands that you write in the Docker file, because I already have like some of these parts like downloaded to my computer with the previous base notebook. The Jupyter Scipy notebook, it's probably just like running the parts where it's like pip install and whatnot. Does anyone have questions about what's going on right now? All right, cool. Yeah, so I just pulled another image onto Docker, and we can see that it's somewhere here. Yep, Jupyter Scipy Notebook. So for this, rather than using the command line, I'm just gonna run it using my the interface. So I'm gonna run the base notebook. And we can set certain optional settings. So as I said, the container, it's completely isolated, but I want to expose this container port, or link this container port where Jupyter is, to my own local port. So I'm going to put a here as well, and we can just run it. So we'll remove some of the other running ones. So it should be up now. And another cool thing is that I can actually look into the command line here. Pretty sure I can. Oh, wait, yeah, we can run commands here. So this is like the shell of this running container. And to actually visit it, I can click on open in browser. Oops. Oh yeah, so needs to have the token, which I don't have, because I forgot to run it when using using the command line, which allows me to which exposes the token. So let me just stop this instance here, and we can run it using the command line. So Docker run, where we're gonna map these two ports, and then just gonna do Jupyter. Do base notebook. Okay. So these should run. That's really weird. I'm not sure why it's not working. Okay, this one works. Right, so now you can see that we actually have a fully working Jupyter instance here. And I can just create a kernel and like, and that should work. Cool. But I think this is just a base notebook, so it doesn't have things like pandas. But yeah, so you guys have seen how we can quickly create a Jupyter notebook or spin up a Jupyter notebook just by pulling the image and running it. And once I'm done with this, I don't even have to like bother with anything. I just shut it down and stop it and delete the containers. So this doesn't really interfere with like my personal computer or what's on my local machine at all. All of these images and containers that I'm running, as soon as I stop it, it disappears into the void. So like it's not gonna affect my computer at all. And that's the really nice thing I like about Docker is because sometimes when I get really caught up with installing like all these different dependencies, I might not be using the right environments. And that just starts to mess with my base Python image on my computer. Okay, cool. Now we're gonna move on to the third and final exercise, which is deploying a basic predictor service. And I am going to send you guys the files for this. Give me 1 second. Okay, so it's the drive link, and it has all of the files that we need for doing this exercise. Let me know if you cannot access it. Okay, so now that you've downloaded it, let's go over what's actually inside of this folder. So first of all, basically we're going to be launching a predictor service that uses a random forest to predict or run on the iris dataset. And this dataset is basically like it gives you the size of like certain flowers, I believe, and it tells you like what kind of flower it is. Um, but I'm not going to go too much into like the actual implementation details of like what's going on in this model, but basically we're just loading the data, splitting it, defining the model, and training and saving the model after we trained it into a pickle file. And our actual application, it reads this pickle file and it runs a very simple Flask API, which you give it like the specifications of the flower, and you're able to it returns the prediction to you. Okay, so we're just going to run the Docker file now. Or sorry, write the Docker file. So one thing I want to do is create a Docker ignore, and just ignore the generate or model.py file because this doesn't really concern the main application, and we're gonna write the actual doc. 1 second, guys. Okay. So again, we're going to use the Python 3.8 base image. And we're gonna set a work directory. We're gonna call it app again and copy the requirements file, which we did not set up yet. So let me do that. Let's do that right now. Take a look at inside of our app file. The things that we need is Flask, Pickle, and NumPy. So I'm gonna quickly, we can set that up. CD desktop. I believe it's inside. Not hello world. We're gonna pull this out. Okay. Sorry guys, another quick technical difficulty problem. Okay, whatever, it's fine. So I'm just gonna CD into this. And then so we're going to make a environment within predictor services. Super cluttered, by the way. And we're gonna call it predictor n. So first thing is just to run the n and call it predictor. And from within the predictor n, we know that to activate this, the actual virtual environment, we're just gonna call the activate.bat file. So cd into predictor m/scripts /activate.bat. Or actually, we don't. So now we can go activate.bat, and we're in the virtual environment. Pip install. So within our app, we use Flask and we use NumPy. Just going to install these into the environment. I also believe we need, pandas and sklearn as well. So we're just gonna install NumPy this side. Learn. Everything's getting installed right now. Okay, so while that's doing its thing, we also need to make sure to add our predictor environment into the ignore file because we don't really need this for our actual Docker container image. And in our Docker file, we're going to copy the requirements.txt, which we have not created yet, but we will soon. So we're going to copy it into app, and we can, or into the current working directory, and we can just say dot. Okay. And I'm going to come out of this to create a requirements file. So pip freeze requirements.txt. So now we have our requirements file here. Cool. And we're gonna run pip install -r requirements. It's sort of very similar to how we did the the hello world example. And finally, we just copy everything else that we need. So that's just going to copy the app.py file over because we have the predictor environment and the generate RF model.py ignored. And to simply start it, we can do Python. So this is a different sort of like syntax for writing it. It's called I believe exec mode, but we can also call commands like this. So this is just going to run the command or spin up the server, hopefully. So now we just do Docker build, give it a tag called predictor service. Now it's building. So one thing is that with Docker, once you build the file once, you don't need to do it again, and it keeps a cache of the build works in a sort of cached way. So like if you make a small change to your original, let's say Docker file, and then you run build again, it's not going to go through everything, but it's only going to go through what's been changed. So now if we actually do Docker run, we're going to run predictor service. Oh, sorry. Okay. It's like it's working now. Yeah, so it's hosted here, and I believe that we can't really access it because we haven't set up the port mapping. So let me close this and run it with port mapping. So we're gonna want 5001 to map to 5001 on our own local computers. If we go here, it should work, hopefully. Okay, yeah, I think there's something with my firewall that's blocking these websites. It was working earlier for me, but for some reason it just everything's breaking down now. Classic case of it worked on my machine. Anyways, yeah, so something changed, and I'm not sure why it's like not working for me anymore. But the general idea is that once I launch this API, I could make a post request to it and it would send back the prediction value. So if we actually look in the app code, it's just going to return the prediction inside of an array once I give it like arguments such as petal length, width, sepal length, and width. But yeah, that's the general idea of it. Sorry I couldn't get it to work with you guys today, but there's just one more slide that we have to go through, and that would be the end of this workshop. Yeah. Okay. So I'm really sorry, guys, that today some of the exercises weren't working well, but basically the Hello World example I did was essentially just the first part of the official Docker guide for using Docker with Python, and I've linked it here in the in this presentation as well. Another thing that you could start doing is just practice using Docker in your next project. Um, and thirdly, learn about multi-container setups. So Docker, as I mentioned previously, it's not really that great if you're just using it for small projects. But I guess the power of Docker is when you actually begin using multi-container setups with it. And there's something called Docker Compose, which allows you to basically set up multiple apps on one computer and have it all interconnect and sort of interact with each other. And yeah, that's the end of my workshop. Thank you guys so much for sitting through this with me. Please let me know if you have any questions.